Heyo! Good to see you again. Today's lesson is brand new. It's rational functions intro. This is our first one of getting into this function family. I think you know what they look like. They've got vertical asymptotes, horizontal asymptotes sometimes. There's usually a space where you can't, the vertical means you cannot go there. So let's talk about these things. And we're going to focus on 5 different areas of this function. And all you have to do today is try to understand how to find each part. Okay, so you have the video, so you can pause it. We're going to go over there. It's in the last one. And actually, he's not there. Sweet. Might be able to do something, get some things done if he's not there. Let's take a look at each area using this function right here. It's on your worksheet. Let me do a quick little... Okay, so use the worksheet, follow it. Here's the function. Let's talk. How do you find the y-intercept of any function? Well, usually you set x equal to 0, right? And then it wipes out all the x values and you're left with one number, like y equals 2. And you find out that's where it crosses the y-axis. Same thing is true here. To find the y-intercept of this function, you take 0 and you plug it into every single location that you have an x. 0 squared minus 3 times 0 minus 10. So all of this gets wiped out. 0, 0, 0. You're left with negative 3 over negative 10, which is 3 over 10. So that is where it crosses the y-axis. But you don't want to leave it like that because it's a coordinate. It's a point, a location on the grid. So let's write it as 0, 0, 0. Yeah, that song's going ahead. Okay, so that is the y-intercept. Plug in 0, that's how you find it. How do you find the x-intercept? How do you do that? Those are the solutions, right? It's where it crosses the axis. So if it's a quadratic, you'd set it equal to 0, quadratic formula, factor, whatever you got to do, and you'd find your solutions. For this, to see where it crosses, you just want to set the top equal to 0 for a rational function. It's kind of similar, right? You're still setting it equal to 0, but we're ignoring the bottom. And you'll see why in a minute, okay? That's an easy equation to solve, by the way. Take the top, set it equal to 0, add 3 to both sides, you got x equals 3. Now, you don't want to leave it like that either, because that looks like the equation of a vertical line. It's a point on the grid, so you want to write it as a coordinate. 3, 0, 0, okay? So y-intercept, x-intercept, sorry. I'm not even going to edit that out. I'm going to leave that in. I don't care. One take, baby. That's how you find those two. Now let's go to vertical asymptotes. Now that word asymptote sounds like a bad word, doesn't it? It's not. It's just an invisible line that the function is approaching, okay? But never going to touch. Though that's not true. Sometimes they do touch. How do you find it? Where the vertical asymptote is for this particular function? Well, now we just take the bottom and we set that equal to 0, which looks like a quadratic in this case. And I think we know how to do this. Minus 3x minus 10 equals 0. Oh, right, because if this denominator is 0, that's bad, right? It's undefined. You can't actually allow that to happen in your function. So it looks like, we know about quadratics. This is going to happen in 2 places. So this function has 2 vertical asymptotes, 2 places in the function where you cannot go. Let's prove it. I would start with factoring. That's what I got. Squeaky shoes. Minus 5 plus 2. Set both parts equal to 0. I'm going to go ahead and do that here. Running out of space. So it looks like we got x equals 5 and x equals negative 2. Okay. Those are vertical asymptotes, places on the graph that you cannot go to. So the function is going to avoid it. In a second, when I go back to the computer and show you, we put the function in and we just take a look at all of these elements and see that they're true. They have to be true. Okay, let's talk about horizontals. This one gets a little kind of crazy. You just have to memorize your rules and have a feel for it. There's 3 things to look at for a horizontal. Number 1, look at the degree of the top, which is a degree 1, linear, and the degree of the bottom, degree 2, quadratic. If the degree of the top is less than the degree of the bottom, it's always the x-axis as your horizontal, okay? So if n is less than m. Yeah, it's on your worksheet, isn't it? I don't like that really, but what we're talking about is if n is this degree and m is that degree, so we're putting in variables to represent, this is always the degree of the top, let's call it n, and this is m, and in this case, 1 is less than 2, so therefore, it's the x-axis. Okay, so that's what we have right now. That one's going to be true. I'm going to give you the other two rules for a horizontal. If n equals m, then it's the coefficients of those two terms, okay? So for instance, if you had 2x squared on top, let's say minus 5, just throw in a minus 5 for good measure, and you had x squared on the bottom, which would be 1x squared, you would just take and look at the coefficients, and the horizontal would be y equals that number. I know that seems strange, but that's what it is. So it'd be y equals 2. Oh, we don't want to circle that one. For our function, it's the x-axis. Well, let's remember that one, okay? Number 3, I think you know where we're going with this. If n is greater than m, if the degree of the top is greater than the degree of the bottom, which it's not in this case, but if it were like this is a 3 and that was a 2, then you have a slant. Which means it's not a horizontal asymptote, it's at a slant of some slope or line, and we have to find that line, and that's later, okay? For right now, we're going to focus on these first two elements, and then we'll work in this one as time goes on to get more familiar. This will be a lot easier in a classroom setting. Just do your best. Okay?
And we're in Desmos. All right, let's take a look at the 5 things that we just did. Number 1, y-intercept. Boing! 0.3, 3/10. Check. Number 2, x-intercepts. Where does it cross the x-axis? 3, 0. Is that right? Yeah, check. Yeah, it was x minus 3. Okay, that works. Number 3, vertical asymptotes. We found them to be at y equals 5. Sorry, x equals 5, my bad. Yes. You know, asymptotes, they need to be dashed lines. And at x equals -2. Probably should be the same. Where don't you think? Yeah, let's do that. Boom, boom. Look at it, beautiful. Now, we want the horizontal asymptote to be at y equals 0, which is the x-axis. Let's make it blue also. And don't be fooled by this one. See, it does actually touch right there. But that's okay because it's still approaching. Look at the ends over here. You can see that the function is approaching 0 as it goes towards negative infinity. And you can see it's approaching 0 as it goes towards positive infinity over here. So yeah, that is the horizontal. And lastly, we have no holes, as you can see. Well, as you wouldn't even be able to see it anyway. Trust me, there's no holes. Okay, back to Big Me.
All right. Sweet, he's not over there. I can do what I want. Sit back, sit back. Jordan, back him down. Oh, for 3. Where did you come from? I'm everywhere. Every time. All right, let's do it. Here we go. All right, here we go. First, where's across the y-axis? Y-intercept. Put 0 in for x in both places and see what you got. Well, that's nothing. And over here we've got 5 over -25, which is -1/5, or -0.2. So how about we write that as a coordinate, 0, -0.2. Okay? So we'll check that in Desmos in a minute. Next, we want the x-intercept, which is where you take this and you set it equal to 0. That's what we did over there. And let's see what happens. So we got a quadratic that we need to solve. Let's subtract 5 from both sides. So there is no middle term again, so how about we just forego that again, sorry, for the first time. 2x squared equals -5. Okay, now let's divide by 2. And we've got x squared equals -2.5. Oh, interesting. Okay, you take the square root of a negative, what happens there? It's imaginary. So what does that tell us? That means it's no touchy the x-axis. It does not touch the x-axis. It better show that in Desmos when we get there. So no, does not touch. All right, number 3, need more room. Vertical asymptotes. This is where you take the bottom and you set it equal to 0. Because the denominator cannot be 0, so this will tell us where it cannot exist, where the function doesn't exist. X squared minus 25 equals 0. You could use quadratic formula, don't. You could factor it, that would be pretty quick and easy. It'd be x plus 5, x minus 5. Or you could just solve with square roots, where you add 25 to both sides. Like that. And you get x squared equals 25. And you take the square root, because the square root has 2 solutions. Plus or minus 5. So I'm guessing the vertical asymptotes are at positive 5 and negative 5. Okay. Let's go over there and look at the horizontal asymptote this way. Oh, okay. So there's 3 rules. Oh, and I'm still looking at them. First one says, if n is less than m, which means if the degree of the top, which is a 2, is less than the degree of the bottom, which it's not in this case, by the way, then it's the x-axis. So let's go to the next one, which says if n equals m. Did you write that down? Okay, good. So if the degrees are equal, then it's about the coefficient or coefficients of those terms. Oh, you see that 2 over 1 right there? So it must be y equals 2. That is where your horizontal asymptote is. Last, holes. There are none. We said if something cancels back here or back at the start, then you have a hole. But since we have 2x squared plus 5, watch out, basketball rim. Can you see through that? Okay, close enough. X plus 5, x minus 5 is the factorization of the bottom. Nothing cancels, can't factor the top. There's no holes. Okay. Let's send it back. No, not back. Forward. Let's go to Desmos.
And we're back again. All right, here's our function, 2x squared plus 5, x squared minus 25 on the bottom. We said that the y-intercept is at negative 0.2. Correct. Vertical asymptotes. We have, oh, I skipped one, sorry. It does not touch the x-axis. No. Look at that, no touchy. We're okay there. Number 3, vertical asymptotes. X equals 5. That's got to be blue because it was last time. And it's got to be a dashed line because I say so. And x equals negative 5. Also blue. Thank you for being blue. Now, oh, don't go away. Now we got to be dashed. Perfect. Number 4, horizontal asymptote. Y equals 2. You got to be dashed. I don't know. I can't really tell. Let's zoom out. Is it approaching? Is it approaching? Is it approaching? Survey says yes. If you were to zoom in right there, I mean, yeah, right there. If you just zoom in, I can't now because this marker's bothering me. There we go. Yeah, yep, it's approaching. It's approaching. It's approaching. Will you get off the screen already? Jeez. I'm having a hard time. Approaching, approaching, approaching. We're good. And there's no holes. There it is. All right. Oh, yeah. Sorry.
And we're done.